So my name is Preet. I work for NXP Semiconductors. So I would say a good audience for me is, so that I can tell you what NXP is and what all we do. So NXP Semiconductor has roots with Philips. You know Philips? So the semiconductor division of Philips got spun off and became NXP Semiconductors, and this was in early 2000. So our roots are from Philips, but now we are an independent entity, NXP, and we are based out of Eindhoven, which is in Netherlands. Okay, and we are world leader in many automotive, many semiconductor domains, especially like in automotive, industrial, and few of the others. Okay. So what I'm going to talk about today is future of automotive mobility, how how things are changing in automotive mobility. Okay, so before I get started, and this is a two-way communication. It's a duplex communication I want to do. I don't want to do a seamless communication where I'm just speaking and you're only at the receiving end. I want you to as active participating in this discussion as I am, and I want each one of you to ask at least one question to me. Okay. I'm not saying that I have answers to all of your questions, but I'll try my best. Ask me anything about semiconductors or in general about electronics. I'll try my best to answer your question, and if I don't have a right answer for you, probably I can come back to you, connect back to you offline and give answer to your question. Okay. So let me and I'm very fond of asking questions. Okay. So what is the very first mobility which comes to your mind? Very first example of mobility. You need to raise your hand, okay, and then say, okay, motorcycle. Anyone else? Very first mobility. Wheels. Okay, only on wheels you can go one place to other place. You need something to, drive that wheels. It could be a bull cart. It could be a camel cart. It could be a horse cart. Okay, anyone else? Very first example of mobility. Someone said motorcycle, the other guy said cart. Legs, excellent. Okay. So by legs, you can go from one place to other place, okay? But what if I say that, okay, you need to go from one place to other place, but you need to get along your family. Maybe you can get along one person on your back, probably two max, but good example. Anyone else in the room? Very first example of mobility. Whatever you think, thought. Sorry? Railways, okay, excellent. Yeah. If you want to bring your whole village, railway is a good example, not only family. Have you heard about Aladdin? Have you heard about how this guy used to go from one place to other place? Flying carpet, magic carpet. Okay, at least that is what strikes my mind when I was kid. Going from one place to other place, you should have some chirag, rub it out. Aladdin will come out, and you ask him any damn thing, he'll fulfill the wishes. He'll take you places, and that was a very good safe mobility. First of all, no traffic jams. No pollution, no petrol or CNG gas refill you need. Okay, so what we are going to talk about today is the future of mobility. The mobility started probably in that Aladdin days, and then this sir gave a very good example. Legs from one place to other place. But if you want to take along the fox with you, then someone said wheel. We used to have bull carts, and at least my grandmother used to tell me that during her wedding days, the whole a set of people, they came on some horse and bull carts, and they used to stay 2-3 days overnight in the in the girls' village, because they used to travel so many miles, in so many days, and then all the bull carts or all the horses need to fed and rest before they take them back. Okay, but here we are, where we are talking about different form of latest mobility using electronics or semiconductor sitting inside it. Okay, so with this we'll get started. I'm part of the NXP India country management team. I'm heading India innovation ecosystem. That's my full-time job, and as like Dr. Padma Sai here, I'm a volunteer to IEEE. So for IEEE, we have a society known as Circuit and Systems. So I'm the chair for Circuit and System Society for Delhi, and that's where, I keep contributing in the technical forums. Okay, so with this, let's get started. Those who don't know NXP, and I think many of you raised your hands, you don't know NXP. So as I said, our roots are from Philips, and we have a experience of 60 plus years, because NXP is NXP got merged with a company known as Freescale Semiconductors back in 2015. And those who don't know Freescale, as like NXP, Freescale got spun off from Motorola. So the semiconductor division of Motorola became Freescale. And then Freescale and NXP got merged in 2015. And that's how we proudly say that we have 60 plus years of experience. We are working out of 30 plus countries globally. And one thing I want you to, really look here, and that's where we take a lot of proud, is 9,500 patent families. So that talks about the volume of innovation we do inside NXP. Okay, it's a 13 billion plus organization, and I hope the number keeps on increasing as we move forward. So this is the width of our presence globally. As I said, we are present in 30 plus countries. If you see, almost all across the globe, in different parts of globe. And one question I keep on hearing very often, and the professor who gave me a free ride this morning, he was asking, do we fabricate our chips out of India? So the answer is no. We do have fabrication all across the globe, but we don't have any fabrication which is happening out from India. But certainly, as you can see, we have some of our own fabs. We have many product engineering or test engineering sites all across the globe. And then we have many of our partners in different part of the world who helps us to manufacture our silicon or chips. Okay, so with this, what you see on the screen are the different main technical domain or technology domains where we work, starting from automotive to industrial to mobile to communication, smart city, and smart home. So as you see, all of these are the trust area which are rapidly growing, and we have presence in all of these domains in one of the other forum. So quickly, I'll talk about NXP India, and then we'll get into our topic. So at NXP, in India we have 4 offices. One in Hyderabad, Bangalore, Pune, and Delhi. Okay, and Bangalore and this Delhi or Noida branch is relatively bigger in size than the Pune and Hyderabad branch. So as I was mentioning in the previous slide, we have about 30,000 plus employees globally, and about 12,000 plus engineering workforce, and almost 1/3 of that is based out of India in different sites. Okay, that's why strategically, NXP India is a very key partner for NXP Global. So I hope next time if someone asks you what is NXP, probably you'll be able to answer it. Okay. Okay, so now let's first talk about semiconductor growth. All of you understand semiconductors? I don't know why this side is so heavy. Is it that the other side is for faculty members? Is there such partition, Dr. Sai? Okay. Okay, so this is student, this is faculty, and these are the VVIPs. Huh? Okay, do you guys understand semiconductors? Anyone sitting in this room who can answer this question? Why we need semiconductors? Anyone? Okay, is it possible to live without semiconductors? If I give you an offer that, you'll get the whatever is your best food, whatever best food, or, a day out in the best of the hotels in Hyderabad, but the only thing you need to do is you need to live without mobile phones. What will you choose? You'll prefer good food or a mobile phone all the way with you? Good food. You serious about this? Because I heard these days that the youngsters, they can live without breath, but they can't live without mobile phones. They can sacrifice any damn thing. I read in the newspaper the other day that someone sold off kidney to buy the latest offering of a phone. I don't want to name the company. Okay, so we are willing to let go our organs to buy the latest gadgets. So, anyone in this room, please raise your hands if you think we can live without semiconductors. That means everyone agrees that we can't live without semiconductors. So then let me ask this question, why we need semiconductors? Yes. Okay. Many applications. Okay. Anyone else want to add up? Looks like another school bus came in or the other section. Okay. So maybe I'll give them some time to get settled here. Anyone else, meanwhile, why we need semiconductors? Can you answer that? Why we need semiconductors? So this guy told these are the basic parts of any electronic system. Is that right? That's what you said? Now this looks relatively equally, balanced. Thanks for showing up. Guys, do you understand what is semiconductors? No? So then this is an excellent class for you. Okay, so let's start, thinking why we need semiconductors. This slide changer is having a semiconductor sitting inside it. The mic I'm holding is having a semiconductor. The mobile phone is having a semiconductor. The display is having a semiconductor. The mic, they have semiconductor. The air conditioner has a semiconductor. The fan has a semiconductor. The laptop has a semiconductor. Any damn electronic gadget which you see has semiconductor in one or the other form, bigger or a smaller way. Now, do you understand what is a semiconductor or why we need semiconductors first of all? Okay, let's take example. How many toothbrush you have inside your home? Maybe this guy in blue shirt. How many toothbrush you have at your home? One for me. How about your family members? How many family members you have? 5. Each one has one of them. So 5 toothbrush in a house. How many electronic gadgets you have in your home? Many. You can't count it. Okay. So that shows the scale of semiconductor. I personally feel that it's very difficult for me to survive a single day on this earth without semiconductors. Okay. Be it, your household stuff, be it your industrial stuff, be it your, communication things, be it your mobility, every damn thing has a semiconductor in it. Because everything is getting miniaturized. Earlier, we used to have big systems, big computers to do compute. Maybe the very first computer, which was more of a mechanical kind of system, probably would have been the size of this room. And now there's a smartphone or computer sitting inside your, pockets. So who made that possible? Semiconductors. Because semiconductors are shrinking the whole of the system. Earlier, we used to have big breadboards, brick boards, and having multiple, I would say, discrete components sitting in it. And now, whole that of electronics is getting inside a chip. We can have millions and millions of transistors sitting inside a semiconductor. Earlier, we used to have discrete such components or on a big size of board. Okay. So with this, let's see this picture on the screen. So this picture shows the growth of semiconductors from 2021 to 2030. Okay. We expect semiconductors to grow at a CAGR of 22 annually, and we expect this number to go up to 1,000, and probably we are talking about 1.2 or 1.3 trillion dollars economy by 2030 in another 4 to 5 years. And if we see each segment, there's a growth. If you see the wireless communication is increasing fivefold, wired communication wireless by 25, industrial by 10, automotive by 20%, and computing and data storage a huge jump of 25, and then consumer electronics by 10. So that's going to be the quantum or size of the semiconductor market in 2030. So out of this $1+ trillion economy by 2030, we at India, we want to be 10% of this market share. We want to be out of this say 1,000 billion or 1,000+ billion dollars, we expect Indian market to grow to 100 billion kind of things. We were about 27 billion in 2021, close to 60 billion in next couple of years, and we want to be 100 billion by the end of 2030. So that's the thrust, that's the kind of vision for us as a semiconductor nation to grow for. Okay, so this particular slide, I'm just trying to showcase you the technology leap forward every 10 years. The first decade from 2000 to 2010 was more on the laptops, desktops, mobile phones, game console, or home audio video things. Fast forward 2010 to 2020, the new revolution was smartphones or tablets or data center devices. So everything became smart. The typical traditional keypad phone became a smartphone. The typical television we used to have at home became a smart television, or a fridge became a smart fridge, or a oven became a smart oven, or a washing machine became a smart washing machine, because there was a connectivity. And the next decade, which we probably foresee at NXP, is cloud and edge computing, so smart connected devices, smart factories and buildings, and smart connected cars. And here I'm going to touch more about the smart connected cars, the future of the mobility, but certainly these are the thrust area. And edge computing and AI is at the driven of heart of it. Okay, anyone from computer science here? Any student or faculty member from computer science department? You're just pointing. You're from electronics? Okay, so because in many of the institute I visit, they said, oh, we have 1,000 students, per year coming into computer science, and maybe 100, 150, or probably 200 getting into electronics. To all my dear friends who work in computer science, you really talk high about artificial intelligence. That AI would need a hardware to run on it. And the hardware will come from electronics or semiconductors. So even you have the best of the algorithms of artificial intelligence, it's of no use if you don't have semiconductors. Okay? So it's like you have a brush, like he has 5 at his home, but you don't have toothpaste. Can't help it. You keep rubbing it, but until unless you have this toothpaste, you can't clean it out. Similarly, you have the best of the AI coming in, but if you don't have the hardware or semiconductors, AI can't run on software. You need some hardware accelerator, etc. Some hardware to run those all AI algorithms. Okay, so that's the importance of hardware, or I would say electronics, in our life. And I always spend whatever topic you want me to talk about, I'll spend first 10 minutes only talking about why we need semiconductors, because that's the core of my job, and I want more and more people working in semicoms. Okay. So let's quickly move forward. So this is something which was covered in TUI a couple of years back during COVID years. Thanks to chip shortage, we were having short of chip supply, and that's where Times of India approached me, and they said they want to cover about this whole chips or semiconductors for India. And this was a virtual panel discussion, online panel discussion. And at the end of the panel discussion, there was a print edition next week. And during that panel discussion, we talked about one topic, which was about semiconductors. And we said that, okay, we have bachelors in electronics and communication in our country from so many years or decades. Why don't we have a bachelors in VLSI? And all the respected faculty members here, we formed a small group and we submitted a proposal to AICET to have bachelors in VLSI. And I was told this is a Panchvarshi Yojana, maybe another 5 years, there will be some committees which will be formed and you might get this as a subject. But we kept working with the AICTE, and exactly after a year in 2022 April, this was in 2021 April, AICTE announced that, bachelor's and diploma courses in VLSI. Because they also realized the, need of the hour, the, I would say, global dominant, which we want to, make India as a self-reliant for semiconductors. So now I think most of the universities, many of the universities, they are running already bachelor's in VLSI. And what I heard in this university, you have already master's in embedded system and VLSI, and probably bachelor's in VLSI coming in the upcoming years. Okay, so let's quickly talk about our world is changing. Any guesses what is changing? What has changed? Technology is evolving. What else? Needs of people are changing, because in early days, people were happy, in my early days, I remember folks were really happy hearing a audio coming out of a radio. So I still remember the first CD player I got when I was in 10th standard. So my brother got in a CD player, and that happened to be my birthday. And all of my cousins, we were just sitting and hearing that audio. We were so happy hearing that audio itself because the clarity of the audio was so good. And we was like, wow. And now, we are not even happy with these gadgets. We want the faster one or a better one. What we see on the screen, can you correlate with all of these? You are more online than ever we were. At least I never thought of, a student of, say, nursery or KG grade knowing how to turn on or turn off a MS Teams, or how to put a virtual avatar on MS Team, or doing a chat with his or her classmates or faculty members. Thanks to COVID, COVID was bad. It impacted almost every single family in one or the other way, directly or indirectly. But I feel from technology perspective, COVID was really good for us. Otherwise, this big digital transformation might have taken decades. The UPI for which we as a country take proud would have taken maybe probably another 10 years to be the reality. Everyone knowing that we can online teach or learn. And we in the industry, whenever we have a tape out, do you understand tape out? Tape out is the step when we send our whole design to the factory, to the fab to manufacture the silicon. So typically the tape out minus 4 or 6 weeks, even if we are inside the same office, we used to get into the big conference room so that we are sitting next to each other and, making things work. Because we assume that if we are sitting next to each other, things would be faster. And during COVID, we did tape out sitting inside our, couches in our houses. Because there was no other way out. Someone said that what, need or is mother or father of something. Anyone remembers that? Necessity is the mother of invention. Okay? And COVID was that necessity which made us to invent, which made us to, learn online or still run our show online. Further, there's huge, huge advancement happening in the healthcare system. I'm fond of analog watches. You'll never see me wearing digital watch. I have probably 8, 10 of them sitting at my home. My family, they keep on using, but I'm still an, fan of analog watches. But these all smart digital gadgets, they can do your probably ECG, pulse to, blood pressure and even your sugar levels and whatnot. This particular picture in the middle bottom, I saw that as reality. Earlier this year, I was in Texas and I saw that robo, passing by me, and this guy was going out for a delivery. So all of these mandate tasks are now reality, with advancement in semiconductors. So with this huge shift, what else is shifting? Our automobile is also shifting. Any guesses what you see on the screen here? At least now I know one person in the room must be knowing this. World's first internal combustion engine car, we call it as IC engine. And this was way back about 140 years, around 1886. In January, this patent was applied, and around mid-year, the physical demonstration was done. And this was by the company Benz. And this is how a typical automobile looks like these days. Full of, wire harnessing, full of other connectivity from one component to other component. The wires itself inside a car is in kilometers of length. Okay? So what do you think? So what is the most important critical part inside a typical car these days? Raise your hands, ECU. What is ECU? Engine control module. Anyone else? Sensors. That was really good. Any other guesses? Come on, guys. They came later and they are answering it. Any guesses? Smart driving. The source itself. Okay, smart driving. I'll be covering that out. Actuators. Sorry? Actuators. Okay. Processors. ADAS. Sorry? Digital interface. Communication processors. Now you're speaking, you're getting warm up. Okay. So I think whatever all you said is right, but there are a hell lot of different other things happening inside the, a typical automobile or a, car these days. And let's quickly talk about that. I don't know how long you'll take to read about everything, but a car is now full of, a system loaded with a lot of electronic gadgets. So let me ask this question again. You need to raise your hands, and I'll not let one person to speak. She already knows the answer because she attended the same talk last week in another town. Okay, how many semiconductors are typically there in a typical automobile these days? Raise your hands. And if you get a exact right answer, I'll ask Dr. Padma Sai to sponsor a chocolate for that particular person. You need to raise your hands. What is a typical automobile? Don't Google, please. What is a typical automobile sitting inside a car these days? Anyone? And there's no right and wrong answer. At least in my vocabulary, in my dictionary, there's nothing right or wrong. Whatever you think is your perspective, just share. 1 lakh. That's quite optimistic. I like it. Anyone else? Any guesses this side? I'm talking about number of semiconductors sitting inside a typical automobile these days.
About few hundred.
Few hundreds. That's a smart one, Yeah. Not an exact figure. Few hundred could be as low as 100. It could be as like as 1 million, 1 billion, 1,000.
Few hundred is usually 200-300.
2 to 300.
Several
okay.
hundred is 700 to 800.
Excellent.
Many hundreds are way beyond. So
Way
that
beyond.
is the scale.
I'm sure you must be a faculty in some good department.
I'm not faculty.
You're from where?
TIFR.
TI?
FR.
FR. What is that? Sorry.
Tata Institute of Fundamental Research.
Wow.
Yeah.
Any other guesses? So we heard 1 lakh from this lady in white. Who's this guy? Please raise your hand. Who said in thousands? Come on, don't be shy. He's telling, oh, this person.
500 to 1000. Back.
500 to 1000.
Maybe.
Okay, the gentleman on the back top with a revolving chair said 500 to 1000. Any other guesses? Let me ask. She told me some answer earlier. How many semiconductors are sitting inside a car? More than 1,000. Okay. Okay, any guesses? What was the typical number of semiconductors sitting inside the car, say 30 or 40 years back? How many semiconductors used to be there? Two or three? Or maybe less than that? Okay, so let me first display the answer here, and probably we can talk about more. Typical car these days would have about 1,000 semiconductors sitting inside it. And this number, as we move forward, we expect this to grow, rapidly in next 4 to 5 years. We are talking about 1,200 plus semiconductors, and these figures might be already outdated. This is the data from 2022. And the amount of, we call it as bill of material, about $640, and this is expected to go 2x in next 4 to 5 years. So that's the kind of rapid growth happening inside automobile semiconductors. Because your automobile essentially is no more a typical mechanical device. It's no more a typical internal combustion engine ICE. It's more of an electric vehicle now. We want to get out of ICE and have an electronic motor driving the vehicle. Okay. We really don't want the earlier days, the steering turning used to be, you should have good muscles if you're driving a truck. It used to take hell of, manual effort. But nowadays you have this power steering with the little finger, even you can move around things. And just to, get your window shields up in typical ambassador car, you used to like, okay, let's keep going. And now you have a single click and you have the power, power windows. The whole infotainment you see in your dashboard is again electronics. So this is the shift happening in automobiles, and now I'll talk about a couple of major trends who are, giving this huge push to automobiles. So there are three major trends which I foresee: autonomy, electrification, and connectivity. So anyone on this room, please again raise your hands. Why you need autonomy inside a car? Why we want an autonomous car? Just raise your hands. As I said, there is no right and wrong answer. Yes, sir. Efficient operation. Nice. Anyone else? Comfort. That's the priority. Sitting inside your home, you can still study. Turn off your video, go sip your coffee, and your faculty is still talking. Any other guesses? Safety. Excellent. For a lazy person like me, I just want to go and sleep inside my car, and I'll, want to get arrived at my destination. Okay, any guesses how many, how many lives are gone in a typical, in a car accident annually? How many fatalities? Any guesses? More than lakhs. More than 1 lakh. Any other guesses? All put together, every fourth minute, there's one, accident or, fatality happening. So I have some figures here. Again, this is one of the data which is not very recent, but typically 1.3 million road traffic deaths occur every year. Okay? And that's a big number. We are losing 1.3 million or more than that life by now every year due to the road accidents or road fatalities. And then there were some surveys done that if you are driving your car with a 30 kilometer per hour, and there are chances of saving lives is 9 out of 10. So if there's a car or any automobile going with a speed of 35, if there are 10 accidents, probably 9 of them would get saved, and that's again a probability. If you increase the speed a little bit, if you go say to 50 kilometer per hour, this count of saving 9 lives becomes almost half of it. I hope the 5 out of 10 can be saved. But 50 is again not that exciting speed, Talk about your ORR, outdoor ring road, I think that's what you say. And I think the permissible limit is 100 kilometers there. 120. It's like heaven. But if you really pedal at 120 and if you're not lucky, you'll be already in heaven. Okay, if we increase this limit, say only to 70 kilometer per hour, the probability goes 1 out of 10. And you already have example of 120 on your roads. So if you're pedaling at 120, then the 10 out of 10 is gone. So that's the need why we need, you know, a autonomous vehicle. So out of all accidents globally, 90% are caused by human errors. Out of this 1.3 million, 90% of those are due to human errors. And that error could be, you just felt sleepy, or you were not focusing, you were just looking a WhatsApp message, or these days I heard people are more excited about the status updates. And there's something I recently learned from my brother-in-law's daughter, and she's just less than 3, about reels and shorts. And I was like, what is a short? To me, it's a cricket short, and there are some small clips I think she's watching these days. But those are, really distracting us. So we can save these 90% of lives if we have an autonomous vehicle. Means if we take out driver from the driver's seat and let him or her sip a coffee and the vehicle is driven by a computer, we can save these 90% of accidents. So that's the importance of autonomous, or someone said ADAS, the other side. And there are different level of ADAS. We have level 0, which is a typical driver manually driven car, to level 1, 2, 3, 4. We already have cruise mode in most of the vehicles these days we drive. And recently I was, having a look on one of the cars that has a ADAS level 2, which is being sold off in India. Okay. The next, topic which we discussed was, let me get back. I don't know how long it will take me to get to that. Was electric, sorry. Electrification. So why we need electrification? Any guesses? Reduce pollution. What else? Replacing fossil fuels. The engine is one of the heaviest things sitting inside your car. If I take out that big engine and replace it with smart electronics, the weight of the car would be reduced. The moment you reduce the weight of the car, your efficiency of the car would be increasing. Okay? And certainly the main reason is getting rid of this all, chemicals which come out of your engine. So typically a car is now no more a mechanical device. It's turning out to be more of an electrical device. That's where, we need more of the mechanical and electrical engineers to be aware about the whole, automobiles. So as I said earlier, that we pushed AICT to start a bachelor's program in VLSI. The other topic which is on top of my mind and my target to work in 2025 is to introduce one semiconductor subject in every single tech domain, engineering domains we have. And I have this submission to all the faculty members here. If you can push your respective institutes to make sure teach a semiconductor subject to every single engineering guy. Because if a civil engineer don't know how to make use of these smart gadgets, this guy can't make smart homes. If a mechanical engineer don't know the beauty of semiconductors, they can't shift the whole mechanical vehicle into electrical vehicle, or they can't play well around with ADAS. If a chemical engineer don't know about semiconductors, they can't make the best of the medical equipments or all the biotechnology guys. Because what we are talking about is you will no more physically need to inject yourself. You'll have these smart devices put on your skin, and this device would know how deep this needs to penetrate and what quantity of medicine needs to be delivered. I'm not saying doctors would be out of job. Certainly they'll have many things. So a couple of days back, I ended up hearing one of the professors from one of the US universities. He was visiting Delhi and I was part of the conference. And he was talking about that, with all this advancement in healthcare, we'll be able to detect much earlier many kind of different medical complications. So ultimately, we'll need more doctors to treat all those patients. Okay, so it's not that with the advancement of technology, the jobs will reduce, rather it will increase. Because we saw the same thing happening a couple of almost 20, 25 years back when there were protests, when we were getting computers inside our offices. All the guys, they thought of, okay, their jobs would be gone if the computer gets inside office. But ultimately, what happened? We had a hell lot of IT industry coming out of it. Okay, so this whole electrification is turning your car to an electric vehicle. And then we are talking about, different other, I would say, kind of alternate fuels. But one thing I want to request each one of you is that we want to get rid of all this pollution by shifting to the batteries. But I could foresee a huge hill of battery coming in our neighborhood. So one of the other thrust domain is battery management. We at NXP have solutions about battery management, but how do we increase the typical life of a battery? And how would we reuse the end of life batteries? So that's one of the domain maybe you guys can, pick up, because ultimately we don't want to, get rid of this whole petrol or diesel engines, but then we'll have pile of batteries coming in, and how do we, recycle all those? That would be an issue. Third topic is about connectivity. Any guesses when we say connectivity, what we are talking about? Can't hear you. Can't hear you. Still can't hear you. Let's be loud. Infotainment systems, okay? So all the whole infotainment you see inside the car, because your car is now a smart car. You can interact with your car. Your one car can interact with other car. Or, we talk about V2V, which is vehicle to vehicle connection, and then V2X, vehicle to infrastructure connection. Okay, let me give you example of typical smart setup these days. First of all, you have this, your morning alarm, which is electronic alarm, which will wake you up. And the moment you are up, probably the geezer sitting inside your bath place would get to know, okay, this guy is up, and they know what kind of warm water I need. It will turn on to get to that level of temperature. And the moment you are taking your shower, your own will get to know, okay, now, I will head and get to my toss, the oven would get turned on. And the moment you are, having your breakfast, your car should know, okay, well, this guy is having breakfast. Now this person will enter inside the car. The car air conditioning would turn on to the temperature I want to. And then you sit inside car, this is an autonomous car which will take you to your place. So these all smart devices are working due to connectivity, because one guy is able to talk to other. Can you tell me why we see so many example of IoT these days? You understand IoT, I'm sure, all of you? Because understanding how a diode works is a difficult thing, but what is IoT would be known to everyone. So why we see so many IoT use cases these days? Sorry? It helps us build the smart system, but why it is happening now, why this was not happening 40, 50 years back? Now we have the necessary hardware, that's right. So can anyone make guess the very first example of IoT? Just raise your hands. Sir, I asked you to raise your hand. Yes, what's your answer? Remote? Television remote? Okay. Any other guesses? A smartphone? Anyone else in the room? So the one example which at least I'm aware of was in Alexa is a good one, yeah. Was in late 60s. If I'm not wrong, that was 1967. There used to be a ATM machine, and that was back in, I think, United Kingdom, wherein you could get a fixed amount using that machine. There was no option wherein you can customize how much amount you want to withdraw, or you can't customize what kind of bank denominations you would get. But that is something more than 50 years back. Then why the hell we see lot many examples happening now? Because now there is a huge connectivity. Earlier days, the connectivity was one of the bottlenecks. And it's not about good connectivity, it's about cheap connectivity. A connectivity which every single household can afford. We as a country, we missed out our first wave of landline phones. We were not able to reach to every nook and corner of India with the landline phones. We kind of failed there. But we encashed the mobile era. Every single damn place within our country, we are able to reach out because it is now affordable. Every single household can afford, even in the rural areas. So since we have now cheap connectivity, and someone said, advancement in technology, because I still remember one of the laptops. I was not having a laptop during my master's, but one of my friends, he had a laptop and there was a separate CD drive used to attach to it. Okay, because this was already a bulky thing. But now we can do much more compute using our mobile phones. So with the advancement of semiconductor, with the shrink of the technology, we can do more compute, and then we have better connectivity and cheap connectivity. That's why we see a lot many examples of IoT happening all around us. So that's the importance of connectivity. A car talking to your gadgets, or maybe a car talking to other car, or car talking to infrastructure. Let me move forward. I think please remind me on the time. I just missed that out. Let me quickly jump onto my slides. So how much time I'm left with, Dr. Sai? 2 minutes, 5 minutes, 10 minutes? She's really kind to me. I think I already spoiled your 25, 30 minutes. And I'm a guy I can speak for hours, Any technology topics. Okay, so what happens in a typical smart system these days, we at NXP, we believe that we have four of these major things: sense. I'm again sorry for this. Yeah, sense, think, connect, and act. You need to sense what's happening, then you need to think, process that information, connect it to the decision-making unit, and then act on it. A typical example is your ADAS or autonomous vehicle where there is no driver sitting inside the car. Now let's assume there is a autonomous vehicle inside a city like, say, Hyderabad, or a city like Delhi I'm coming from. And a typical Indian scenario, there is a big poly bag which is up in the air due to good wind, and the car comes across this flying poly bag. So now the car needs to find out, first of all, what kind of object it is, detect it. And now based upon this object detection, the car need to categorize whether it's a human, a bird, or a piece of paper, or a poly bag, and take a decision. If I hit that object, am I going to hurt this object? Let's assume if there's a bird, am I going to kill a bird? Or if that object hits me, is it going to harm the car or a driver sitting inside the car? Okay, so you need to sense, you need to think, you need to connect, and then you need to act, whether I need to apply brake or whether I go left or right. And then there's another topic which comes into picture, which is because this is whole hell lot of AI running, is AI ethics or ethics in general. So let me ask you this, uh, there are some case studies. There's one case study like there's a pregnant lady on the road, there's an elderly gentleman on the road, and then there's a young kid on the road. So if the situation is like that the car needs to end up hitting someone, which one this car should hit and why? And they are different, No, the condition is that you can only save 2 out of those 3. I would love to see a scenario where you can save all 3 of them. But then car needs to take a decision, because if this guy hits this pregnant lady, it's going to kill 2 lives. If this car hits this young guy who has like another 30, 40, 50, 60, 70 years to live. And then the decisions could be of the elderly gentlemen, but we do care about our seniors. And then there was another thing, what if, and that's a typical India scenario I asked many times, what if there's a cow and a, buffalo on the road, which one you'll hit and why? And the question will be which state you are riding this car. That will decide. So it's not only semiconductor, it's not only hardware, there's a hell lot of science or, other things behind it. And then another question comes about AI ethics. How ethical your decisions are. And the next question comes about the whole AI training, because ultimately this whole AI is, learning based on some training. And these days, our data available on, web is a polluted data. It's a synthesized data. And if the AI is only learning based on this biased data, then ultimately you're going to take a biased decision. I think I gave this example many times in my previous talks is, men at work, why not women at work? And if your AI is being trained with this, ultimately every single time it's going to take the wrong decision. It would be gender biased. Because ultimately there's a human at work. It could be man or woman. So it's not only the semiconductor or only the electronics. There, many things which as a technology we need to talk about and take care of it. Again, these are different examples of sense things connect and act within NXP. This is just a quick example about again different kind of electronic gadgets sitting inside the semiconductor. In the interest of time, I'm going to skip. Vehicle architecture transformation, I'm not going to spend much time. Quickly, I just want to talk about, the architect of a vehicle is changing, and it itself is a, our plus topic, but I can quickly talk about, typically today's the architecture is a flat one. What people are talking about is a logical restructuring, creating different domains. And what we see is, creating different zones. We want to create different powerhouses or different main zones inside the car, and then they work in coordination and take a decision. But I think instead of that, I'll spend more time in this particular slide. So vehicle transformation underway from hardware-oriented vehicles. So this is what a typical hardware-oriented car is these days. Functions tied up to ECUs. This guy told me ECU. He's busy on his phone now. Static architecture, exponential increase in complexity. But what we foresee as we move forward is a software-defined vehicle. What you see on the right. So your car would be like your smartphones. The moment you have a new operating system in your smartphone, the whole look changes. So similarly, the cars will keep on getting upgraded themselves. And what we at NXP say that the moment you buy a software-defined vehicle, it is in its worst shape the day you buy it. And as the time passes by, the car will become better and better because the car will understand, your habit of driving. Probably your way of sitting, so that the moment next time you are inside your car, let's assume a single car is being used by husband and wife, and the moment wife gets into the car will understand, okay, here she comes, the fair gender, she will this car would adjust from the seating to the cooling to all the setup. Okay, it will turn on your Kishorda kind of songs, and if there's a Gen X guy, probably some other later songs. So that shift is going to happen. And as you keep on using it, this will become better and better and better. And one of the typical example we talk about in many of the technology, discussion these days are, this is again a live example which has happened that you bought up a car and the car company realized that the ground clearance of the car is not good based on all the data this car company was gathering. And they said, okay, if I increase the ground clearance by another 3 centimeter, I think this will be better in performance. So if you really want to increase the ground clearance of your car these days, what you need to do, every single car needs to go to the workshop. They'll probably adjust something in the shockers or add up another layer there. But what this SDV will do, you put up a program, push enter next day morning, every car is elevated by 3 centimeters. Because there is such a huge electronic setup sitting inside the car, they will increase the suspension or decrease it. So that kind of shift we see in the software-defined vehicles as we, move forward. Quickly, now I'm gonna shift again gears to talk about a couple of initiatives we do at NXP. We strongly believe in brighter together, and when we say together, it is with our partners, with our customers, and with our ecosystem partners. With all the academic R&D institutes, and we have some of the initiatives happening back in NXP, and I just want to introduce those initiatives here. This is one of the topics I was talking to the professor who gave a free ride this morning to me, is about artificial intelligence and mobility. We do this annual challenge, and this is about 2024 challenge, which was held, and we did 3 regional finales, one in Hyderabad, one in Bengaluru, other in Noida. We got about, I think, 1,800 plus participants, 1,800 plus participants entering in this, and finally, getting to 16 teams in the regional finale. And all those 16 guys, they got this particular hardware kit. It's like was $500, $600 kit, which we gifted to these guys. And then these students say, okay, so this is, we call it as a challenge, but it's a learning challenge. We first train you how to use this, and then you need to go and perform, build your models and work on it. So all those kids, the 16 teams, they got this hardware, they received training from NXP, and ultimately we did a grand challenge back in October in Noida, where our CTO was there, and I think prizes were 3 lakh rupees or something was given to these students. So I think it's a very good learning opportunity, and I can very confidently say that all those 16 guys who worked on this particular hardware kit would have gone a good placement already now. One of the other initiative which we have is NXP Campus Connect. So it's a virtual session which we do twice every month, every first and third Tuesday of the month. The time is fixed. You can go and register. There is no fees attached to it, and it is open to anyone or everyone. I have seen a lot of faculties attending these sessions along, apart from students. So one of the NXP experts would come and talk about one of the latest technology topic in these sessions. Other initiative is about women in engineering, and I should congratulate Dr. Padma Saisi, a very good, diverse, crowd here. Typically I have seen, very less percent, probably 1% of the whole crowd being women, participant. So we have this initiative, Women in Technology, wherein there's an annual call we do. I think we got last time 8,000 application. Anyone who's part of any engineering course within India can apply for this. And I think this needs to be a second-year student. And then there's some screening process. There are even some written tests and interviews. But if you're lucky enough, like we got 60 girls selected in the last round, then you are gonna get trained for next 1 year by our channel partners, free of cost, and those will be industry level courses. And you are going to get 50,000 rupees of cash award as well. One of the another initiative is regarding startups. We do this startup challenge every year, and the call for 2025 would be out in first quarter of 2025. So maybe if you have some startup wing here, which is typically the case in any academic institute, please do plan to participate. I would like to rest here with the single statement change. There's one of my favorite quotes, and this quote come from one of this guy, Charles Darwin. And it says that it's not the strongest which will run, which will win in the long term. It's not the most intelligent or, not the gold medalist or your class will be, winner in the long term. It's the person who's adaptable to the change. If you keep on learning, keep on changing, keep on upgrading yourself, then only you can, win this technology race. So with this, I'll stop here. I'll be more than happy if there are any questions. I'll be still around here for some time to answer any questions. So any questions here?
How is the session? Can you clap, all of you? Okay, thank you, sir, for covering it. So if I give time, sir will teach from morning to evening. So not only teaching, he will work like that. So I am having experience to work with Preet sir during first time AP CAS conference came to India. That is happened at T-Hub. He used to work from morning to night, mid one, and early morning he will get up and he will do run like horse. Okay, so not only for doing such things, in his industry also he used to work like that. Everyone should be on our toes. If you want to learn technology, so you should be ready for that. Okay, already sir mentioned about where you should be active and try to, I want to see some of you are going to join NXP by the time next time Preet sir is visiting our institute. Are you ready? Very good. So thank you, sir, for sharing your valuable thoughts to all our students and all the participants and faculty members. Definitely, we will aim for, we'll meet your expectation. I can proudly say that only one college in AP and Telangana, we didn't shut down core branches. Whatever strength we are having, we have retained them. And actually, first First college, we have started MTech in VLSI, only college in AP and Telangana, only one college. We started in 2003 VLSI system design. And before you inform to AICT, we approached AICT for VLSI. They have given permission, unfortunately, for a UG program, but unfortunately our university, they doesn't have that program. They didn't give us permission to start. And this year also, once again, we are applying for that. We hope it will come. But in our electives, we are having separate tracks from third year onwards. They can choose only subjects in VLSI area, communication area, or suppose if they are interested in AI and machine learning, they are having exclusive tracks are available. Because of that, we are able to place our students in Synopsys, AMD, such companies too. Thank you, sir. We want to see our students in your company. So I request our principal sir and Murli Mohan sir and TSR sir, please join us to honor our guest. Sir, please, sir. Our principal sir. Yes, sir.